All right. So as I said, this shouldn't take very long. Just this little set of notes on glaciers. Uh, so oftentimes glaciers are referred to as rivers of ice because they do flow, they do move. Obviously, not as quickly as a river, uh, but they do share some characteristics as well as some differences. So the way glaciers form, and this is kind of specifically talking more about one type than another that we'll talk about, but um, snow accumulates at higher altitudes. Above the snow line, which, like it says, is about 15,000 feet above sea level. Above that altitude, it stays cold enough to where it's cold enough for snow to not melt all year round. So it doesn't matter if it's, smack dab on the equator. If it's above 15,000 feet or so, it's going to be cold enough, and that snow's not going to melt. So when it snows more, it just builds up and builds up and builds up and builds up and builds up. And snow and water, it weighs a lot. So that snow, as it piles up, is compressing the snow beneath it, which is going to turn that to ice. Just like if you make a snowball and you really compact it, you really put a lot of pressure on it, it'll basically turn into an ice ball. Those are the kinds of snowballs that you don't really want to use in a snowball fight. You need to try to keep things peaceful. So the weight of the snow that accumulates compresses that snow into ice, and then along with gravity, that ice moves down the slope to lower elevations. So that's where it moves. It does flow, like I said, although a lot slower than a river. But it is created because of accumulating snow at high altitudes where it stays cold, all the time, and that snow never melts. So this is, that relates to this specific type, so this valley glacier or alpine or mountain. It is in mountainous regions, high altitudes. We have some in the northern Rocky Mountains. Alaska has a bunch of glaciers. Canada, there are a bunch in Europe. Obviously, we don't have any here in Indiana for many reasons. And these can move up to several meters a day. So, that could be, 6, 8, 10, 12 feet a day, which, considering how much material there is, how much ice there is that's moving, that's a lot of energy. And that it has a lot of force behind it because that's a lot of weight. And it's just, it's a lot of power. So this little diagram, just kind of shows that. So here, if we have the snow line here, so this is that, about 15,000 feet above that is where the snow is not melting. So it just builds up and keeps building up, and that weight is just forming ice. And then I was also kind of pushing, that ice down the hill. And as it's moving, it does warm up to some degree because it is at a lower altitude. And also we have these things, crevasses. When the glacier needs to, go over some sort of a formation, ice isn't very good at bending or stretching. So it breaks and it forms these crevasses, which are large cracks in the ice, which can be very dangerous. Some are not very deep and some are not very wide, but others are, they can be hundreds of feet deep. Some are even covered by snow to where you can't see them until somebody steps, on top of it and they fall through. So mountain climbers are constantly probing the snow with ski poles and hiking poles to make sure that there's solid ground. But this is a picture of of how mountain climbers get across crevasses is with ladders. So they carry these ladders with them, and then, depending on how wide the crevasse is, then they strap them together and walk across them. So another thing that happens with glaciers is a process called calving. And this is when pieces of the glacier break off where it meets water. And there are all kinds of videos, YouTube videos and stuff of the waves that this creates, like swamping the sides of boats and knocking people off rocks and all kinds of stuff. There are even some places where people surf the waves that these pieces of ice breaking off the glacier create. Now, granted, they have wetsuits and jet skis that take them around, so they can ride the waves, but they do it. This is also where icebergs come from. Is when pieces of ice calve off of glaciers and then they float out to sea. So that's where
Titanic.
What's that?
Titanic.
Yeah, exactly. So the same thing that could can sink ships and all that. This is at one point in time that ice was part of a glacier. The other type of glacier is this continental glacier. So this is much larger. This is more of an ice sheet that can be large enough to cover a continent, which Antarctica is a great example of, because the entire continent is pretty much covered by a glacier and covered by ice. In some places, it can be thousands of feet thick, which is kind of amazing to think about. That certain places you could stand there and just have thousands of feet of solid ice beneath you. But they do move, even though it is slower, and the movement's a little different because it's not so geared towards one direction as far as down a valley, but it just kind of spreads out in kind of all directions, more or less. One term is moraine, and especially this lateral moraine. So as these glaciers are moving, they pretty much act like a bulldozer, and they just plow everything that's in front of them. So as this glacier is moving, down this valley, it's picking up and moving all kinds of sediment. It's it's weathering rock on the sides of the valley, and it pushes all that material until it stops moving. So the sides, these piles on the sides, those would be lateral moraines, because lateral means side. Like if you have lateral movements, you're moving side to side. This pile at the end, that would be a terminal moraine, because that's where the glacier terminates. It's done. Now, when this glacier retreats, so if it warms up and it retreats and melts, it leaves all of this stuff here. So glaciers are responsible for a lot of geologic features, because of all this material that is moved, because of the area that they've covered. It's kind of smoothed those out, because anything that was irregular, it's plowed that smooth. One sign that glaciers have moved through an area can be rocks with these striations on them. So it kind of looks like layers. Looks like it could be sedimentary rock. But what's happened is glaciers will essentially move all the material, out in front of it, all the way down to bedrock until it's just scoured it clean. And then other rocks that are in between the bedrock and the glacier, as the glacier is moving over the top of it, it's pushing down on those rocks and scratching the bedrock. So anytime the scientists see, stones and bedrock that have these scratches on them, they know that that's from glacial action that, glaciers moved through that area. Plus, it also gives a direction of movement because the scratches are obviously in the direction that the glacier moved. And something I've mentioned at least once, I think, is that glaciers will form U-shaped valleys. So we talked about fast-moving water producing V-shaped valleys, but glaciers produce a much smoother U-shaped valley because, as it moves through that valley and is, plowing its way through it, anything that's really sticking out, more so than anything else, is going to, basically just be, moved out and, ground down, and it leaves it much smoother. It's not going to be that sharp V. It's going to be a much smoother U shape. But this is also a good indicator that glaciers have moved through an area where there are mountains. And then this next, I don't know, kind of feature or sign of glacial movement are erratics, which, if something is erratic or someone is, acting in an erratic way, they're kind of unpredictable. They don't really do things that you would expect, and it's typically not a good thing if somebody is acting erratically. But in terms of this rock and others similar to it, which they don't have to be this big, but erratics are rocks that basically don't belong there. Like, they shouldn't be there based upon the other types of rocks and the type of bedrock that are in that area. So here in Indiana, for example, we have limestone bedrock, but there are erratics here because Indiana was partially covered by glaciers. So, it's possible to find, large rocks, some could be this size, but like I said, not all. These rocks could be made of granite, which we don't have granite here. We have limestone bedrock. But what's happened is in Canada, they have granite, and that's what their bedrock is. So as the glaciers moved in from the north, it's pushed those rocks all the way from Canada down into Indiana. And then when it warmed up and the glacier started to melt and retreat, it leaves all of that stuff, where it sits. So those are possible to find. I mean, they're around a lot of times around fields, like for farming. There might be some there because over the years, farmers have found those because they obviously don't want large rocks in their fields. So they found them and removed them. But a lot of those are from the glaciers. So the glaciers have brought them down. And, if you, like I said, Indiana was covered a few times. It's also one of the reasons that the northern part of the state is super flat, whereas the southern part has hills. It's because the northern part of the state was, covered by glaciers a few times, which, again, pushed a lot of material smooth and just flattened everything out. And then this last little bit just has to do with that, that there have been multiple ice ages. That here in Indiana, we've been covered by glaciers a few times. The last one was about 11,000 years ago. And those ice ages and those glaciers, that's why we have the Great Lakes. I mean, when all that ice melts, that water's got to go somewhere. So those were the low-lying areas, and that's where the Great Lakes came from, was all that melting of the glaciers. All right, does anyone have any questions, or are there any slides I need to go back to?